Okay, the question says the 6 faces of a cubical die are numbered with 2 to the power 0 all the way to 2 to the power 5 in such a way that the product of the numbers on any pair of opposite sides is 2 to the power 5. Okay, two such dices are stacked on top of one another. If n is the greatest sum of the 9 visible numbers, find the sum of the squares of the digits of n. Okay, so the most of the focus that we have to do here, most of the work will be done on figuring out the number n, because finding the sum of the squares of n is going to be the easy part. So the majority of the work will be done on figuring out what is capital N. So what are we given here? So we have two dice that are stacked on top of another. So let this be the two dice. This is the first one, which will be on the top, and this is the second one, which one will be at the bottom. So each die has 6 faces. So in total, both of them will have 12 faces. This is 6 faces, this is 6 faces. The total will be 12. But when we stack the one at the top on top of the second one, two of them won't be visible to us. Also, the one with the bottom one will also be not visible to us because it will be held at some floor or some table. So this won't be visible to us either. So 3 out of the 12 won't be visible to us. So we are remaining, there are only 9 faces. So only those 9 faces will be visible. So that much is clear. Now what you are saying is that so there are now 9 faces remaining. So each face will have some number, and we have to put the numbers in such a way such that the sum of the numbers is as high as possible. So this is going to be the sum of the numbers capital N, and we have to try to maximize the number n. But we also have some criteria, as it is mentioned in the question, that the numbers are stacked such a way that the product of the numbers on any pair of opposite faces is 2 to the power 5. So suppose we have one face here and one at the bottom. So if you multiply those numbers, it has to be 2 to the power 5. So this is not very complicated. Suppose we have 2 to the power 0 times 2 to the power 5. We know that when you multiply two numbers with the same base and different exponents, the result is calculated by summing up the exponents, which is equal to 2 to the power 5. So what are the combinations? It's very simple. So let me write it down. The numbers. So if you add 0 plus 5, we get 5. Oh, okay. Let me also write down the values. What's 2 to the power 0? It's equal to 1. 2 to the power is 2, 4, 8, 16, and 32. Okay, now 2 to the power 0 and 2 to the power 5, if we multiply them, it will come up to 2 to the power 5. Similarly, if we multiply 2 to the power 4 with 2 to the power 1, so when you add up the exponents, 4 plus 1 is 5. And finally, if you multiply 2 to the power 2 with 2 to the power 3, So when you sum up the exponents, 2 plus 3 equals to 5. So these are the three pairs that you can use. Okay. Now what's the total sum of all the numbers? So if 32 plus 16, which is 30 plus 10 is 40, 46, 46 plus 2 48, plus 2 50, 58, 62, 63. So the sum of all the numbers is 63. So we have cube 1 with 63, we have cube 2 with 63. But as I said, some of the numbers have to be removed. So let's start with the bottom one. At the bottom there will be two faces that is not going to be visible. So we have to try to put two numbers that add up to be the least, out of which, if you can see here, so again we'll also have to take care of this pair. We can't just randomly put any number. So when you add up 8 plus 4, it comes out to be 12. When you add 16 plus 2, it turns out to be 18, and when you add 32 plus 1, it turns out to be 33. So out of these three pairs, which one is the least? This one, 2 to the power 2 and 2 to the power 3. So we'll arrange it in such a way such that 2 to the power 2 and 2 to the power 3 falls in these two places. So out of 63, 12 is removed. So we're left with 51. Now coming to the top one, here this face won't be visible. So what we have to do is we have to put the least number here, and also remember that there is only one face that will be invisible here, that won't be visible. So what's the least number? Is 2 to the power 0. So simply we have to arrange it in such a way such that 2 to the power 0 falls here. So we are actually removing 1. So it turns out to be 62. Okay, so that's it. Now what's the definition of n? N is the greatest sum of the 9 visible numbers. So we have figured out that there are 9 visible numbers now. For the top 5, the sum is 62 of the remaining 5 faces, and for the 4 faces here, the total is 51. So if we add that up, 62 plus 51 is 2 plus 1 3, 6 plus 5 is 11. So this is n. So n equals to 130. So this is the greatest sum of the 9 visible numbers. Okay. So we figured out the value of n. Now we have to focus on the final part. Find the sum of the squares of the digits of n, which is a very simple thing to calculate. All you have to do is sum of the square all the digits and sum it up, which is nothing but 1 plus 9. So 9, 10, 11. So this is the sum of all the digits, sum of square of all the digits of n. So this is our final answer, 11.